This project's an idea that I had about the crawl space has a constant 66 degrees in it. If it's 0 degrees outside, the crawl space is 66 degrees. If it's 95 degrees outside, the crawl space is 66 degrees. So I saw that as a great resource of temperature controlled air. And what I want to do with that is I want to build 2 circulating fans that brings that 66 degree temperature up into the living room. And in order to do that, I bought a 20-inch fan is the first one I'm going to buy one company, and I'll buy another 20-inch fan from another company and see which one's better and which lasts longer. But in order to get that air from a 20-inch fan to a 4-inch diameter pipe, I need to make 2 cones that will direct it into a 8-inch pipe. I found this here 8-inch diameter as a connector that I will take the 8-inch diameter cone and connect it to this, and then this will go into the 4-inch pipe. So in order to start these cones and figure out how they are, I started with a internet circumference calculator, and on the 8-inch diameter it had a circumference of 26 inches. Well, I'm only going to use 90 degrees of this, so that's 3/4 I'm not going to use. So this area here is going to have to be the same distance as the 8-inch diameter. So I took that circumference, multiplied it by 4, and then I found the radius of what that would be on that circumference. And that's just 1/4 of the larger radius, but yet when this end touches this end, it should be right at 8-inch diameter. I did the same with the outside diameter. On a 20-inch circumference, I multiplied that by 4, and since I'm using only 1/4 of it, 90 degrees, I found the radius that would take to do that 4 times. And so when it touches this end, it should be a 20-inch radius, or a 20-inch circumference, excuse me. 20-inch diameter is what I meant to say. Here, in order to get 2 cones out of a 4x8 piece of FRP board, I had to design how to do things, and I began by putting some tape over it to give it some reinforcement. If you go to bend these FRP down to 8-inch diameter, it's going to be good chance it's going to crack on you or something. So the Basement Doctor people gave me some of their good white tape. I think it's about 5-inch wide, and we did 95% of this 4x8 piece of FRP board, and I'm hoping that's enough reinforcement that if I'm careful, I can bend this into an 8-inch diameter at the small end. But I made a couple of mistakes on this over here. I didn't follow my designs, and my pivot hole I put in the wrong place, and I did one bad one. Then I thought, well, I'll just move it a little bit and do another one. But I found out and looked at my prints again, and first hole I used was over here as a radius, but it should have been 6 inches from the bottom here like I used over there. But I got 2 cones out of here, and I'll take a tin snips now and just carefully cut all this out, and hopefully we'll get those 2 cones together, and that's the first part of the job. After we laid out our 4x8 piece of FRP material, we put a couple layers of Basement Doctor tape on it to give it the rigidity. You can see when I first started this project, I made some models, and that's when I found out that putting tape on the material really strengthened it and gave it its ability to maintain itself. So after I laid them out on the 4x8 piece of FRP, I cut them out with a 20 volt 7-inch circular saw, and put 3 or 4 pieces of cardboard under it, cut about an 1/8 inch through, and they cut out real nice and easy. Then I let them curl a little bit in this frame to kind of get their shape into them. And then I put a bucket on top and let it set for a couple days, lower the bucket another inch or two, let it set a couple days, lower the bucket again another inch or two, until it's pretty well in its form that it's going to be when it's done. Here's one that I've got done. I took this board and connected it here with 832 screws all the way up, and it went together real well, and I put a piece of tape over it. And then up here, I used my circular saw to cut grooves in here and allowed me to pull this up through here, and these are like little tabs, and I put 832 screws in here, and that came out real nice and rigid. And but these are the materials that I need for the job. 4-inch pipe, a few 1.5 by 1.5 boards, I guess they call them 2x2s. And here is what I connect up to the underside of the roof. I use this kind of as a guide. My wife holds that, and I center this up through the 4-inch hole I cut in my floor. And in order to make it easy to screw on, I hold these with a piece of roofing material rubber, and it holds these real well where I don't have to do anything but bring up my gun and tighten them in. So these are the materials that I used. You can see this piece on the top here is an 8-to-4 reducer rubber. Comes in real handy. But this is about all the material you'll need on this job, and the cone came out real nice. I'm going to go to finish this one up, and then I'll assemble the unit. Well, here's the final product that I made and designed. Came out nice looking and everything, but when I turned it on, I was thinking that the fans would push the air up to the 4-inch and get plenty of air up there. But the 4-inch pipe is really restricting the airflow, so I am going to redesign things and learn a few lessons from this episode. We have completed the air circulating units, and the temperature showing now down here is about 68 degrees. Before I opened up the registers, it was 66 all the time, so there's a little more warmth down here, a couple of degrees. But this temperature will stay the same in winter, where it's 20 degrees outside now, and at 95 degrees it will remain constant also at 68. So I just wanted to use this air to help my furnace and air conditioning units, and it seemed, I hope it's working. This is the first unit. I got 2x2s coming down onto the joist and holding the cradle for the fan. If the fan goes bad, I just untape my tarp and raise it up, pull the fan out, put another one in. Pretty easy exchange. But I used a 6x8 tarp, anchored it up around the registers at the top and sealed them. And then I sealed the seams along the side with duct tape, and seems like everything's holding well. And it does a good job of shooting the air up into the living space. There's this second one. It's basically on a 14x14 register. This register is 14x20. I've got two 14x20 registers built and one 14x14 built. This is the third unit here, built the same way. Wasn't too difficult. Had to do some wiring to get it set up, but it came out nice. And as I crawl over here in a crawl space, I'll just give you a quick view of my radon mitigation unit. To drain out the gravity flow drain that we put in, you just cut that little slot open there, open it up, pull the hockey puck up, and it's back to a good drain unit. You need to have good return ducts so that your air can have someplace to go when you shove it up there, and this is one of the return ducts. I put flexible ductwork hooked tightly to it. It will shove the air back into the sunroom and help circulate the air out of there a little bit, and that way we're circulating air in the total crawl space. We are going to turn the system on. Again, it's a very easy wired system to where when you want to turn these on, you just come in and flip the switch and they go on. We usually run these from morning when we wake up till we go to bed. And I believe the cost of these, if the mitigation fan is 23 cents a day, we figured that these fans individually should take less power than that mitigation unit. So I'm thinking anywhere from 35 cents a day to maybe 70 cents a day is the cost of this unit to pay for the electricity. So we'll show you the registers now. These are registers made by Shoemaker, made in USA. Very good quality. They are, you have to watch yourself when you order the color. They ordered light brown and they came in a greenish gray color. I called the company and they says that's exactly the color they should be. So I bought a couple cans of spray enamel, put 2 or 3 coats on, and they came out pretty respectable, and the color's kind of respectable. But I told you downstairs this was 10 by 14. This is actually 14 by 20 on this register. And the system is shoving air well enough that I can reach as high as I can and still feel the good breeze up here. So the air movement is excellent, and the units as a whole are functioning very well. Now, when I turn them on, the house is reading a decibel level about 40. I've got a decibel meter here, and turn it on, and I could see what the house is without the fans on. And because I'm talking, these are be invalid numbers you're looking at. But if I was to bring this down and take a reading, it will read around 47. So the decibel level that this creates is less than the furnace, and when it's a rise from 40 to 47 decibels, during everyday life, you won't even hear them run. In fact, you probably can't hear anything now. But this is the first register here, and it's functioning very well. I've got 3 units. This is the second unit. This is 14 inches by 14. And when you cut the holes, cut them about 1/4 inch bigger than you think, so you don't have to file and do all kinds of custom work to get the registers in. But you got a little extra slop when you do that. And I took screws, 1-inch screws, on all the sides and used them like jack screws. And now all these registers are solid and will not move around because there's jack screws holding them right in place. I did that with all of my registers. Since we're here, we'll take a quick reading on our radon meter, and it's been in here for 6, 7, 8 months now. It's reading 2.3, very safe. The level is 4.0, is a safe level. These are at 2.3. So this register here is very nice, fits well, sits in there well. I've got these cracks in the floor. I've got to do some work on it to find out. In the wintertime, they show up. In the summertime, you can't see them. So I don't know if there's any cure on those cracks, but it's only on boards that go the whole width of the house that these cracks show up, the long distance range. So we'll have to get with the pros and see if we can get that cured. I'll show you the return ductwork that I put in. I got 2 6 by 12 registers here, and got them anchored well, and that gives me about 12 by 12 return air duct size. I've got the same setup in this closet, a 12 by 12 system of return air duct. I have on the other side of the bed here another Shoemaker register that is 14 by 14. That's the one that goes into the 16-inch flexible ductwork to the underneath the sunroom to get the circulation going everywhere down there. I have 2 more return air ducts in our washing machine room, and they're out of the way, and they are anchored well that they don't get moved around. And I have figured the return duct square area to be about 10 square inches more than the ductwork, or the register size that brings the air up. But I don't know how effective this is, but I've always thought about this. Basements where I live, that's cool air all the time. How can I use that resource of temperature controlled air? And so thinking about it for years, I finally started the project, did the project. I don't think I did any harm to the house and how it functions, and I feel like I am doing some work where my furnace and air conditioner have some aid in getting their temperature control where I want them. So I'm happy with this job. It came out well, and I'm glad it's done, and I'm glad I did it.